Today we're going to look at page 3 of the Chapter 11 AP Chemistry packet, and we're going to be considering heats of solution. Heat of solution is how much heat is either absorbed or released when you dissolve something in water. Let's take a look at what has to happen to dissolve NaCl in water. So we're going to dissolve NaCl in water. Now NaCl is soluble. You know that from everyday life. You also know it from your solubility rules because Na is a group 1, and you know Cl brickles trickle except for the happy tickle, and Na is not part of that happy tickle. So let's see what has to happen in order to dissolve NaCl. First of all, you're going to have NaCl, and NaCl right over here is made up of Na pluses and Cl minuses. It is a ionic compound, and so what you want to do is you want to break up. You have to overcome the forces of attraction, which is the lattice energy of the Na plus and the Cl minus. So you have to split these up into separate ions, and that's going to involve the lattice energy, and this is a positive number because you have to put in energy. Next, you're going to have to disrupt the hydrogen bonding of the water and split up the waters from one another, and so that they can go with the salt, and this is also going to involve a positive delta H, or change in heat, and you're overcoming the intermolecular forces. In this case, they were H bonds for the water. Lastly, what's going to happen is these individual little ions of sodium and chloride are going to be surrounded by the water molecules, and they're going to form these arrangements here where the water is going to surround the ions. So since the Na is plus, it's going to be, Na right here is plus, it's going to be surrounded by the O's of the water because the O's are negative. And here is the Cl minus in the middle here. It's going to be surrounded by the H's of the water because the water is polar positive towards the H. So this process is going to be negative because we're forming these clusters of water around the ions. This is called solvation. It's also called hydration, if you see that word. Hydration refers to water, and the water surrounding the ions, and this is a negative. So remember, we learned with bond energy that brochendo is breaking bonds. It's endothermic when you break bonds, and this one is going to be formexo. It's exothermic when you make bonds. So the combination of these three, plus, 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 and minus, is going to determine if the overall heat of solution right here is going to be positive or negative. So let's suppose that all these add up to a negative answer. That means that it's going to release heat. It's going to feel hot. This is the principle used in hot packs. So foot warmers, hand warmers for going skiing or snowboarding, they're going to release heat. They're going to feel hot because their hydration must be very, very exothermic right here, and it makes the whole thing negative. Contrast that, if you have a positive answer for your heat of solution, that's going to be like a cold pack, which you might get for an injury. Use one of those chemical ice packs. Those packs are cold because they are positive in their heat of solution, and that's going to be either that their lattice energy is so large or their solvation is so small. Whatever the combo is going to result in a positive answer. So this is going to help you with the book problems that ask you questions about delta H1, delta H2, delta H3, or the heat of solution.